Hello everyone, this is a Vissim video today, and I got a question about a school drop-off, now how to model that. It involves some rerouting, changing some routes, queuing, and some kind of like a logic, how to do it, like marshaled or traffic managed queuing. So you can see the school is in the middle. You have like these access roads. The red one marks the queuing area. And so vehicles will queue up here. You need to access the school using this link, but to get here, you need to first queue here. If this is full, then you move on here, you U-turn and get into a queue here. And when there is space, you drive up to this shoulder, and this shoulder will discharge vehicle into this, and so on. In this model, in this example, I have vehicles coming from east and west, so left and right. And everyone needs to come into this shoulder first. So they need to drive. U-turn here. If they come from here, they will get on to the shoulder, into the shoulder using that connector. When the queue here reaches the end, vehicles will drive down here and enter the using this U-turn, the shoulder. These intersections are always stop intersections, and while drop-off pickup vehicles wait in the shoulders, general traffic still should be able to use all intersections. So when this is full, vehicles will wait here and they will only get here when there is space. The same goes here. When there is a vehicle here, they wait here to keep these clear. So there are different ways to do it, and I will show you 3 different ways. In this video, we will look at the simplest one when we use formulas for the routes. In the second video, I will use attribute modifications, and in the third video, I will use Vissim. Basically, all models will do exactly the same. So let's have a look. What do we have? We have some basic conflict areas to control gateways. We have priority rules to control, to keep the intersections clear. We have stop sign for the all-way stops, yeah. We have vehicle routes covering and setting out. Let me just list. We have static routes doing that and that. We also have static routes from the other side. These are for general traffic. These two are for school traffic. I split traffic into 2, background and school only, separate vehicle type, separate vehicle class. As you can see, it is set here. And school has this route. Pay attention that this way, this static route only shows this main road, the shortest, the simplest. And the other one is from the other way, from that. We will need to change these routes using one of those options I just listed to make them come down here when the queue is there. So how do you do that? In this video, I'm going to use formula-based routing. Let me just say a quick thank you if you commented, liked my previous videos, or if you subscribe. And if you join as a paying member on YouTube or on Patreon, I really appreciate your support. Okay. As you can see, let me just list. There are partial routes. A partial route is basically overtakes the static route. It overrides a section within a static route. So like a local distribution you can set. So this partial route starts here just before the U-turn. And this is the first option. And this is the other option. So what we will do, we will change these between these two. We will assign all vehicles into this. If there is no queue, if there is space. Once this fills up, we will stop, we will zero out the relative flow. And we will assign a relative flow of 1. So 0 and 1 will mean that all vehicles will go through the route that has 1. So when a vehicle arrives on the static route, gets to this partial vehicle routing decision point, and here his route will be updated. It will take this long one or the short one, depending on our formulas. The same goes to the other side. So we have a formula-based partial routing here too. This is the main, the default one. And there is that one. Again, we will use formulas to switch between these two. How do we calculate formulas? So if you look, here you can set the route choice method to formula. That way, this grays out the relative flow, and the formula, if you click there, you can input a formula. If I unhide the detectors, you can see that I have a detector placed here, here, and all along the route vehicles can take. This detector is used as an end of queue detector. If you see, it is not at the end, so there is a little bit of gap, so it gives a little bit of safety area. If one more vehicle, if like two vehicles come very close to each other, there is still place. And just to avoid some issues that vehicles will block back the main line, the general traffic lane. I also have a small short detector here. It is important that these are short. These detectors, however, cover the whole area. These detectors are only on locations where vehicles go, school vehicles only go to these links, connectors, if this is full. If you check the detectors, you can see that all of them only activate on vehicle class 70, that is the school vehicle type. So you can see that there is a school vehicle class and the vehicle type assigned 630. If you go to vehicle types, you can see 630 school card. So I just basically duplicated this, named it school. Also, you can see, to help during the simulation, visually to observe, I assigned the color distribution of black for the background and white for the school traffic. This way you can distinguish and also confirm that your model worked properly. Okay. So now, just to double click on the detector's activation, you can see only school is selected. So what we do is we use these detectors to check occupancy. If the occupancy is more than 3 seconds, then I trigger the partial route change. So that means if this detector is occupied for more than 3 seconds, then I trigger the change. This is the reason it is a short detector, and this is a short detector. And also there is a 3 second and not just 1 second or 0, or I say that if there is a vehicle on it, because what happens? If a vehicle turns, as it drives through that, it will drive through for around 1-2 seconds. So I need to make sure that I use like a relatively longer delay time, or occupancy time, let's say 3 seconds, to eliminate that chance that a vehicle driving across it would trigger a change. Otherwise, a vehicle turns here, and if immediately another vehicle comes behind, that will be directed down. But this one, is from another way. So as you can see, this detector is the end of the queue. This detector, again, is just an end of the queue, just to make sure that if there is, for any reason, a vehicle got stuck, then I'm not going to feed more through that. So that way, it's like basically a detector checking for blocking the main line. You probably wouldn't end up having a vehicle there, but just for safety. And these detectors, on the other hand, these are on connectors that only be used when a vehicle is actually going down those connectors. So if a vehicle is driving here, let me run it. And let me just show you what I mean. So as you can see, this is filling up. I just put a stop sign here so vehicle wait, let's say half minute. So I can build the queue up. So now the queue is there, a vehicle arrives. Or vehicle is already arriving, so I missed a little bit of time. So if I just so you can see these vehicles go there, that vehicle goes there, U-turning vehicle getting in, and they are filling up. And background traffic, the black one works fine. And the reason they stop that because it's all red, all-way stop, yeah? So that's why they give way. And as you can see, this only gets in when there is gap. But this one is going to stop there and wait until there is a gap. So let me just show you quickly how I do that. So priority rule here. And I placed two conflict markers, one here. And this conflict marker is all vehicle type because I only let school vehicles through here. But you can just set it to school if you want. And the mean clearance is 6 meters, so I just set this, meaning if there is a vehicle waiting here, it's gonna wait there. Then there is another conflict marker here that has 22-meter clearance. That is just long enough to be after the priority rule. So once this vehicle leaves, passes that priority rule, it covers this whole area. And here as well, so if you look, this conflict marker just goes beyond that. So this means no one will get through this point as long as there is a vehicle along here. So that way, even if a vehicle is driving there, this won't be a wait because there is this covering that whole area. Just make sure that this marker stops after that, yeah, and not before. Otherwise, it can be a very funny situation. So now, and I use the same here. So priority rule, I cover a bit of gap here. Then I use another one covering that. And after that, the reason I don't have a very long, because that way, if you give a very long headway there, this would go back here. So you don't want that. All right. So now we have vehicles still getting in the queue. And soon the end of the queue. So now if you look at it, if I select the detector, if I put occupancy, you can see it is 22 seconds. So now this vehicle, if I list the partial route, you can, the relative flow changes in a way that it will assign all vehicles down there through that. And you see this white vehicle has already paused the U-turn. So that white vehicle is going to go all the way down. And it is blocking the detector as well. So occupancy is increasing. So from now on, every vehicle we see even. So if you look at it now, that vehicle left. So when these vehicles get closer, the detector will get empty. But even now, these detectors will keep the occupancy through the whole route. So it will make sure, and it will ensure that someone is coming either from there or there. We go down and not going to use the short. One more thing, since we use detectors, it's important that the port number is the same for all detectors. It is key for this code to work. So if one detector is occupied, all detectors are occupied. I will do a separate video about that to explain in a bit more detail. Just make sure that the port number is the same for all detectors. And you will need to do a dummy signal controller just so you can add detectors. But you don't need to do anything, add anything, just an empty dummy signal controller. So now, if I just keep running the model, you can see that vehicle will start basically going back. And that vehicle weighs that as long as there is someone driving. So, and since that vehicle is just after that, and now as it drove off, it will go. And this also, it gives weight there and stops. And now they are waiting and we keep filling up that as it moves. I think it's a really cool little model and very useful. So let's just go into the important stuff then, and let me explain the formulas. In the formulas, as I showed, we use detectors. In a table lookup, so I have a video about this, how to use that. If I don't forget, I will link it in the description. In that one, I explain how table lookup works. Basically, you click that, you click this, and then you select detectors. I just need to find it, detectors. And variable name, it just use anything you want. I just use that. So later we just use that. So in this table lookup, we can find something that is not related to the object we want. So we have partial vehicle route. If you use table lookup, you can access objects that is not related to the object you are using. So we are using this formula for a partial route that has nothing to do with the detector. So it's very easy to just find something and use information from that object to use it in another object, basically. And this table lookup is a thing that you can use with attribute modifications or in any other location where you have these formulas. So then you just say basically detector port number. So in this one, you set a condition in the second. Excuse me. Sorry. So in the second section in this table lookup, because the first is you describe what object. In the second one, you describe the condition. So what I say here, I say I want to find the detector that has a port number of 1. Basically, it will find all the detectors. So all detectors will qualify or will be returned. But since we share the same data across all detectors because we use the same port number, it doesn't matter. So port number 1. Then in the third section here, you describe the output. So this will describe what goes into here, the relative flow. So here I just have a little if, and what it says, if the detector the detector, it returned here by that, which means basically any detector or all detector, the occupancy of that, if that is more than 3, so again, in the table lookup, I have an if in the results section. So that detector has an occupancy more than 3, then I return 0. For this will be 0, or 1 if it is not more than 3. So if the detector that this condition returned, if that detector has an occupancy more than 3, then it's 0, or 1 if it is less. That means I change the relative flow bit from 0 to 1 or from 1 to 0, depending on the occupancy. So if the occupancy is more, that means there is a vehicle here. That means I need to put 1 to the other route. Then I put 0 here and 1 there. I deal with the other route in a different way. So as you remember, it was 0, 1 in the end, and here it's 1, 0. So this route goes 1 if if the detector is occupied, and goes to 0 if the detector is not occupied. Just basically copy pasted this whole thing and just change these 1 or 2. And here you don't need to use if or anything, you can just put a number, but this way is dynamic and automatically keep updating both. And I have exactly the same for the other route. So this was the partial routing we looked at now, this. And the other one has exactly the same. You can just copy paste. These change the same way. So the first one, the short one, is 0, 1. This one is 1, 0. And it works like a charm. And basically, you can achieve this change. You can override that relative flow. You can calculate that relative flow here using this formula, or you can also use attribute modification, or you can also use Vissim. I don't know which one you prefer. I think for me the easiest one is Vissim, because I think this table lookup and if can be a bit confusing sometimes. But I think if you do all 3, you will find which one fits you better. Thank you very much for watching, and keep subscribed if you want to see the other ones. See you in the next one.